Welcome to this explainer. When we think of AI these days, we're usually picturing a tool that, writes our emails, whips up funny images, or maybe helps us out with some coding. But there's a quiet, multi-billion-dollar revolution happening right now in scientific computing, specifically in meteorology. Today, we're unpacking a really fascinating development, how AI is literally being taught to predict the weather, and we'll look at why China's massive investments in this space could completely reshape how entire economies respond to the future. Let's dive in.
Imagine waking up tomorrow morning to a forecast that isn't just, a generic 30% chance of rain on your weather app. Instead, imagine a system that tells you exactly where that rain will fall, precisely when sudden urban flooding is going to start, how a cyclone is going to shift over the next 3 hours, and exactly which coastal areas need to start preparing first. And here's the kicker. Imagine getting all that critical information way faster than today's forecasting systems can currently deliver. Because, in the world of extreme weather, time isn't just information, right? Time literally saves lives. Now, to really grasp how AI pulls off this kind of speed, we first need to take a quick look at how we've been doing things up until now.
So for decades, the old-school way of forecasting has relied on something called numerical weather prediction, or NWP. And the basic idea is actually pretty incredible. Scientists collect an absolutely massive mountain of data. We're talking temperature, atmospheric pressure, wind speed, humidity, radar, satellite observations, the whole shebang. That giant pile of data is then fed into mathematical models based on strict laws of physics. Finally, extremely powerful supercomputers crunch all those numbers to simulate how the atmosphere is likely to behave. It's a remarkable system, for sure, and it's totally transformed how we predict storms. But there's a catch. It is incredibly computationally expensive. The atmosphere is just immensely complex. To put it in perspective, it can take a massive supercomputer, like roughly the size of a tennis court, several hours just to simulate a few days of weather.
Basically, traditional NWP says, all right, let's calculate exactly what the atmosphere should do by solving complex physics equations completely from scratch. It's super rigorous, but man, it is slow. AI weather models, on the other hand, take a completely different approach. An AI essentially looks at the data and says, hey, I've seen this movie before. It's already analyzed millions of historical weather patterns, so based on exactly what the atmosphere looks like right now, it instantly recognizes what is most likely to happen next. Instead of doing a massive physics calculation, it's using rapid pattern recognition. Once an AI model is trained on decades of historical data, it can churn out a highly accurate forecast in just a fraction of the time it takes a traditional supercomputer. It is a total game changer.
Section 1. China's AI weather race, building a new strategic ecosystem.
As reported by Reuters, we're seeing this build into a major geopolitical race, with China emerging as a highly significant player in this new technological frontier. Recent reports highlight several major AI weather forecasting systems currently being developed in China. First up, you have Fangwu, developed by the Shanghai AI Laboratory, which represents a whole new generation of global forecasting models. Then there's Pangu Weather, developed by Huawei, which has actually grabbed international attention for its ability to generate forecasts at totally unprecedented speeds. And we've also got Fuxi, developed by researchers associated with Fudan University. Now, what we are seeing here isn't just, a few isolated pieces of software. It is a unified ambition to build out an entire AI weather ecosystem. They are combining the AI models themselves with vast data centers, massive computing power, deep meteorology expertise, and satellite observations into one giant integrated infrastructure.
Now, the absolutely crucial point here is speed. Let's put this into a real-world scenario. Imagine a deadly typhoon is barreling toward a densely populated coast. Meteorologists are tracking it, but the storm keeps shifting. In a traditional system, you generate a forecast, and then you wait. You have to wait for the supercomputers to calculate the next massive batch of equations before you get an update. It's an agonizing computational wait time. But with AI forecasting, that cycle is drastically shortened. You can run the AI prediction, instantly update the storm's trajectory, and forecast again almost immediately. This rapid update cycle allows authorities to track and respond to those chaotic storm movements in close to real time.
Section 2. From prediction to decision. Decision intelligence for entire economies.
Okay, let's really dive into this and see why this speed isn't just about giving you a slicker weather app on your smartphone, but about creating fundamental decision intelligence that powers entire industries. What's really fascinating here is seeing how different physical industries can instantly respond to AI forecasts to protect their resources, their money, and their infrastructure. Take aviation.
If an airline gets a highly accurate, rapid AI forecast, they can proactively reroute flights around severe turbulence, which saves fuel and keeps everyone safe. In shipping, massive cargo vessels can adjust their routes long before they ever hit dangerous swells. For agriculture, knowing hyperlocal rainfall probabilities means a farmer can delay irrigation by 24 hours, saving massive amounts of water. Energy companies can anticipate exactly when a heat wave is going to spike air conditioning demand, or when heavy cloud cover will drop their solar generation. Smart cities can even link this weather data directly to their traffic and drainage systems before the first drop of rain ever hits the pavement.
What we are really witnessing here is the fundamental evolution of weather services. Think about it. The first generation just gave us information, telling us what the weather is doing right now. The next generation gave us prediction, using physics to tell us what it might do tomorrow. But this new AI generation, it moves us to action. It's about triggering automated physical responses. Imagine a global logistics system that automatically reroutes a supply chain because the AI detected a 15% increase in cyclone probability along a major shipping corridor. The forecast literally becomes an active participant in running the world. Section 3. The hybrid forecasting future. AI and meteorologists working together.
But hey, before we get too carried away with all this hype, we've got to ground things a bit. AI forecasting is not magic, and we definitely aren't looking at a future that blindly replaces human meteorologists. AI actually has some very serious limitations that we have to keep in mind. First off, the atmosphere is just inherently chaotic. Tiny shifts can produce vastly different outcomes. Second, AI models learn from history, right? Well, that means that extreme, unprecedented, once-in-a-century weather events, which are exactly the events that cause the most damage, are incredibly difficult for an AI to predict simply because it hasn't seen enough examples of them in its training data. And finally, an AI is only as good as the data it was trained on. If that historical data is incomplete or missing high-resolution inputs from certain parts of the world, the model's performance is going to suffer dramatically.
Because of those blind spots, the most robust forecasting systems of the future will not be AI only. They are going to be hybrids. As this quote so perfectly sums it up, physics tells us what is possible. AI helps us recognize what is likely. Traditional physics-based models will still absolutely need to be there to set the foundational rules of the atmosphere and to catch those unprecedented anomalies. AI will sit right on top of that, bringing rapid pattern recognition and incredible computational efficiency. And human meteorologists? They'll sit at the very top of the chain, providing context, checking the models against each other, and making those ultimate crucial judgment calls when human lives are actually on the line. Section 4. The opportunity for India. Connecting intelligence to action.
Let's apply this locally and look at India, for example, a country that is highly exposed to severe monsoons, cyclones, and rapid urban flooding. This kind of AI could be absolutely transformative there. Instead of a simple alert that just says, heavy rain tomorrow, imagine an integrated AI system operating in a massive city like Mumbai or Bengaluru. The AI generates the weather forecast, which instantly calculates a neighborhood-level flood probability. That probability feeds directly into a traffic impact model, highlighting exactly which specific roads will be submerged. This automatically alerts emergency response teams to pre-position their resources, while simultaneously sending business continuity recommendations to local supply chains. We are talking about changing a simple weather alert into highly actionable decision intelligence. Chaining all these events together so that the city is actually reacting to the flood before the water even starts rising.
Section 5. The bigger geopolitical story. AI as national infrastructure.
Now let's zoom out to the macro conclusion, because this specific weather story reveals something much, much more profound about the broader global geopolitical race. For the last couple of years, the public conversation has been almost entirely focused on the first wave of AI, systems that generate digital content. We're talking about chatbots, coding assistants, and image generators. Fun stuff. But the next wave, the one that will arguably have a far greater impact on human survival and economic stability, is scientific AI. This is AI that generates intelligence about the physical world. We are talking about unleashing massive neural networks for climate modeling, drug discovery, material science, and energy optimization. This is a massive leap from the purely digital realm into the actual physical reality that we all inhabit.
An impartial look at the global ecosystem shows that countries are no longer just competing over who has the smartest chatbot. The strategic competition spans entire verticals now. It starts at the hardware level with AI chips in massive data centers. Then it moves up to the foundation models. And finally, it branches out into applied systems like scientific AI, robotics, and climate intelligence. In this context, rapid weather prediction isn't just a neat scientific trick anymore. It is a core component of national disaster preparedness. A country that can anticipate extreme weather faster than its neighbors has a huge, distinct advantage in protecting its agriculture, its maritime operations, and most importantly, its citizens.
Ultimately, when AI stops being just a novel digital technology and becomes vital infrastructure for physical decision-making, it leaves us pondering a truly massive question. Who will build the smartest systems for understanding and influencing the real world? The race to predict the weather isn't just about meteorology anymore. It's a race to build the operating system for the physical world itself. Think about that next time you check your forecast.